Good morning to all of you. In previous sessions, we have seen examples for identifying discrete Fourier transform by using fast Fourier transform, that is FFT. We have seen first example where we have identified 8-point DFT by using DIT FFT algorithm, while in second example we identified 4-point DFT using both DIT FFT and DIF FFT algorithms. In today's session, we'll be discussing one more example where we'll be identifying 8-point DFT using DIF FFT algorithm. So here is the example. Here we have to determine x of k, that is nothing but discrete Fourier transform by using DIF FFT algorithm. So here we will be using decimation in frequency algorithm for identifying this x of k for the given discrete time signal x of n, which is given as x of n is given in the functional form, that is x of n is equals to 2 raised to the power n, and here the value of capital N is 8. That means we are going to identify 8-point DFT here, right? So initially we'll write down all these samples in the given signal x of n. So in solution, the given discrete time signal x of n is, so if I'm substituting n is equals to 0, so 2 raised to power 0 is 1, right? Then that means this will be your origin sample. Okay, so the origin sample in the signal x of n is 1. Then for n is equals to 1, it will be 2 raised to power 1, that means it will be 2. Similarly for 2 it will be 4, for 3 it is 8, for 4 it is 16, for 5 it will be 32, for 6 it will be 64, and for 7 it will be 120. So these will be the 8 samples. Okay, this is for n is equals to 0, this is for n is equals to 1, 2, 3, 4, 5, 6, 7. Okay, so 0 to 7, total 8 samples will be there in x of n. Okay, so while identifying the 8-point DFT by using DIF FFT algorithm, again here we'll be using this 3-stage butterfly structure, right? So here we are identifying DFT using DIF FFT algorithm. Okay, so as it is 8-point DFT, so again we'll be drawing these 8 parallel lines, right? Okay, so in DIF FFT, input will be applied in sequence. Okay, so this will be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and x of 7, while the outputs are decimated. Okay, so if 000 is there, so its reverse will be 0, 000 only, so the first output will be x of 0. Next one is the 001 for 1, so if you reverse it, so it will be 100, so it will be x of 4. So when you are decimating these outputs, so those outputs you will get in this order, that is first you will get x of 0, next x of 4, next will be x of 2, next will be x of 6, next x of 1, then x of 5, then x of 3 and triple 1. So reverse it, so you will be having triple 1 only. So that will be x of 7. So in case of this DIF FFT algorithm, again we are using 3 stages to stage 1, then stage 2 will be there, right, and finally there will be stage 3. While the structure of stage 1 in DIT-FFT will be drawn in stage 3 in DIF-FFT. Okay, so in stage 3 we are computing 2-point DFT, right? So on dropping line we'll be multiplying it with -1, right? Similarly here it will be -1, and here it will be -1. Okay, and where there is -1 in output, basically in DIF FFT we are multiplying this Twiddle factor in output. Okay, so here it will be W8 0, again W8 0, again here it will be W8 0, again W8 0. Okay. While in case of DIT-FFT, these Twiddle factors were multiplied in inputs of these stages, right? So again in stage 2 we are computing 4-point DFT. Okay. So on dropping line again -1 will be there. Here again computation of 4-point DFT will be there in stage 2. So where there is -1, you are multiplying Twiddle factor in output there, right? So here Twiddle factor will be W8 0, right? Here it is W8 2, again W8 0 and W8 2. Okay, and finally in stage 1 here you are computing the 8-point DFT. Okay. So on dropping lines again you are multiplying it with -1. The output you will multiply it with Twiddle factors. So Twiddle factor W8 0, W8 1, W8 2, and W8 3 will be there, right? So let's initially compute these values of Twiddle factors, right? So your W8 0, so this w8 w and k is nothing but e to the power minus j 2 pi k by capital N, right? So in this case it will be simply e to the power 0 will be there, right, as the value of k is 0, right? So 0 multiplied with this complete quantity will be 0, so w80 will be 1, right? Similarly, w81 you will get it as e to the power minus j 2 pi by 8, so it will be e to the power minus j pi by 4, so it will be cos pi by 4 minus j sin pi by 4, right? So when you compute these values, cos pi by 4 and j sin pi by 4, so you will get this w81, so that is 0.707 minus j 0.707 will be there, right? So this is here w81. Similarly, w82 will be e to the power minus j, k value is 2 in this case, right? So 2 multiplied by 2 will be 4, so it will be 4 pi by 8, so it will be cos pi by 2 minus j sin pi by 2 will be there. Okay, so here this 4 divided by 2 will be 1 by 2, right? So here it will be simply minus j pi by 2, correct? So if you put these values again, cos pi by 2 and minus j sin pi by 2, cos pi by 2 0, minus j sin pi by 2 sin pi by 2 is 1, so it will be simply minus j, right? So that will be the value of w82. And the last Twiddle factor is w83, so it is e to the power minus j 3 multiplied by 2 will be 6 pi by 8. Okay, so it is e to the power minus j 3 pi by 4, so it is cos 3 pi by 4 minus j sin 3 pi by 4 will be there. So if you again put the values of cos 3 pi by 4, cos 3 pi by 4 is minus 0.707 plus j sin 3 pi by 4 is again 0.707. So this is w83. Now you can write down these Twiddle factor values here as well as whatever inputs that you are applying, right? So x of 0 is 1, right? X of 1 2, x of 0 is 1 here, right? X of 1 is 2, x of 2 is 4, and then 8 16 4 8 16 32 64 and 128. So these are the inputs, right? w80 is 1, right? So wherever there is w80 we'll be writing 1 value. Okay, w81 is 0.707 minus j 0.707, w82 is minus j, w83 minus 0.707 minus j 0.707 will be. w82 is minus j, right? So it is again minus j, here it is minus j. Now let's compute these values. Okay, so here as you can see 1 is coming here as it is, right? And the another value coming here is this 16, correct? So this 16 is coming from this way, right? And 1 is coming from this side, so 16 plus 1 will be 17. So this 17 will go to this stage 2 as an input, right? But before computing stage 2 outputs, we'll initially compute all the outputs of stage 1. Again here 2 is coming as it is, and from this side this 32 is coming, right? So this 32 plus 2 will be 34 here, right? Similarly this 4 is coming, right? Then this 64, so 64 plus 4 will be 68 at this point, right? Similarly here 8 plus this 128, so it is 136, right? So all these 4 outputs will be input at this stage 2, okay? That is 17, 34, so those will go here as it is, okay? In this case again this 1 is coming from this side, right? So here it will be 16 multiplied by minus 1, so minus 16 plus 1, so it will be minus 15, right? Again here you will have this value that is 2 and minus 32, so it will be minus 30, right? Then again at this point we'll be having this 4 and 64, minus 64, so it will be minus 60 here, right? Again at this point you will have value 8, right? And minus 128, so it will be minus 120, okay? So here input will be 17, then 34, then 68, 136, right? But here this minus 15 getting multiplied by 1 Twiddle factor, so it will be minus 15 only here, right? Input. So here also I'll write these inputs. 17 will be as it is, 34 will be as it is, 68, 136, right? But here these outputs are getting multiplied with this Twiddle factor, so it is minus 15. Then you will be multiplying minus 30 with 0.707 minus j 0.707. So here you will get it as minus 21.21 plus j 21.21, okay? After multiplying this minus 30 with this Twiddle factor, that is W81 0.707 minus j 0.77. Here it is minus 60 multiplied by minus j, so it will be simply here j60, right? Here again minus 120 multiplied by minus 0.707 minus j 0.707, so you will get it as 84.84 plus j 84.84, right? Okay, so now here we'll be computing stage 2 output. So this 17 is coming here, it is from this side, this 68 will be coming, so 68 plus 17 will be 85, okay? This will go here as it is, right? 85. Then similarly from this side 34 will be coming, right? Then 136, so 34 plus 136 will be 170. This 170 will go here, right? Okay, then at this point 17 minus 68, right? So 17 minus 68 this 16 will get multiplied with -1, right? And here it is 1717. So here multiplication you will get is -51, right? So this -51 multiplied by this Twiddle factor 1, so here it will go as -51. Then here at this point you have wait a minute. Okay, so from this side again 34 will come here, right? At this point, right? And from this side -136, so -136 plus 34, so here it will be -102. This -102 get multiplied with -j, so here the input will be minus minus plus will be there, so j 102 will be the input, right? Okay, let's compute the next outputs. So here -15 is there, and then it is getting added with j60, right? So output here will be -15 plus j60, which goes as it is at this point, so -15 plus j60, right? At this point again this -21.21 plus j21.21 will get added with this value, that is 80, not minus 84.84 plus j84.84. Okay, so this addition here is basically 84.84 minus 21.21 will be there, so it will be 63.63, right? And plus j, so here it is 21.21 plus 84.84, so it will be j 106.5. Okay, so here we'll get 106.05, I think, yes, 106.05. Okay, so this will go here, that is 63.63 plus j 106.05, right? At this point. Okay, here again -15 will be coming, then j60 minus 1, so minus j60, so it will be -15 minus j60, right? -15 minus j60, so this will go as it is here, right? Multiplying it with 1, so you will get same value, so their input will be -15 minus j60, right? Okay, so again at this point again -21.21 plus j 21.21 will get added with this -84.84 plus j 84.84 getting multiplied with -1, so the addition of 21.21 is getting added with this 84.84, so you will get this minus 63.63 and again minus. Okay, so So here it is getting multiplied with 2 minute. Okay, so here you will get minus 21.21, right? So here 84.84, so minus sign will be there, so addition will be there, right? So it will come basically 106.05, right? Then this will be there, that is minus j 84.84 plus 21.21, right? So here you will get minus j 63.63. Then it will get multiplied with this minus j, so here input will be there 106.05 plus j 63.63. Okay, so let's compute the stage 3 outputs here. So this 85 will be coming as it is, right? And from this side this 170 will be coming. So addition is 255, right? Here 85 minus 170, right? So 85 minus 170 is minus 85. It will get multiplied with this one. So here you will get output as minus 85. Here minus 51 is coming. Then plus J102, right? So minus 51 plus J102 will be there as an output. Here again minus 51 will get added with this minus J102 multiplied by this again 1, so you will get minus 51 minus J102, right? Here this minus 15 plus J60, right, will get added with 63.63, so minus 15 plus 63.63 will be 48.63. Okay. And this J60 plus J106.05 will be plus J166.05, right? So here again this minus 15 plus J60, then this minus sign will get multiplied with here, so minus 63.63 minus 15 will be again that total addition result at this point will get multiplied with 1, so same result will remain as x of 5, right? So here it will be minus 78.63, right? Minus 78.63, and then this minus J106.05 plus J60, right? So here you will get minus J46.05, right? Then at this point again you will have this value, that is minus 15 minus J60, then this 106.05 plus J63.63, right? So here when you compute this 106.05 minus 15, okay, so here you will get 91.05, okay, and this minus J60 plus J63.63, right? So here it will be plus J3.63, right? This is nothing but this 63.633 minus 60. Okay. So here again this value is coming, that is minus 15 minus J60. Okay. So at this point you will have this minus 106.05, then minus 15, so then minus 15 minus 106.05, right? So you will have minus 121.05, right? And then again with minus J60 and minus J63.63, so it will be 123.63, okay, multiplied by 1 will be remaining same. Okay, so these are the stage 3 output in this case, right? You just cross verify a certain calculation here, so if I have made certain mistake, then you please correct it, right? But this is nothing but how this DIFFT algorithm is used to compute the 8-point DFT, right? So in this example we have used what DIFFT algorithm for computing the DFT, that is 8-point DFT of x of n is equals to 2 raised to the power n. So we'll try to write down the final DFT here. So here I'll write down all the values that we have computed, right? So the DFT of given signal x of n is equals to 2 raised to the power n is x of k is equals to, so at x of 0 we have 255, then at x of 1 we have 48.63 plus J 166.05, then x of 2 is minus 51 plus J 102, right? X of 3 is 91.05, then plus J 3.63, right? Then x of 4 is minus 84, 84 or 85. Okay, so it is minus 85, x of 4 is minus 85, then x of 5 is minus 78.63, minus J 46.05, x of 6 is minus 51, minus J 102, right? And then x of 7 is minus 121.05, then minus J 123.63, 63. So all these are the required values of DFT, correct? So this is how we have computed DFT 8-point DFT using DIFFT. So in next session we will be discussing the realization of discrete time systems, where we will see the structures for the realization of discrete time system, and then we'll try to discuss the basic realization block diagram and the signal flow graph. So that we will be discussing in next session. Thank you for joining this session.